This video is about Descartes' rule of signs. This goes along with studying polynomial functions. Descartes' rule of signs. Let a function f of x be defined a polynomial function with real coefficients and a non-zero constant term, with terms in descending powers of x. The number of positive real zeros of the function either equals the number of variations in sign occurring in the coefficients of f of x, or is less than the number of variations by a positive even integer. The number of negative real zeros of the function either equals the number of variations in sign occurring in the coefficients of f of negative x, in other words, you're going to substitute negative x in for the variables, or is less than the number of variations by a positive even integer. Or is less by a positive even integer just means you can decrease that number by 2. Let's look at an example. Determine the different possibilities for the numbers of positive, negative, or non-real complex zeros of the function. So we have f of x equal to 3x to the fourth plus 2x to the third minus 8x squared minus 10x minus 2. So in this polynomial, in variations of sign, if you look at this, f of x, you've got positive 3, positive 2, negative 8, negative 10, and negative 1. So how many changes of sign do we have? Positive to a positive, that is not a change in sign. Positive to a negative, so there's a change in sign. Negative to a negative, that is not a change in sign. And negative to a negative, that is also not a change in sign. So for this function, the number of positive zeros is equal to 1 because you had only one variation or change in sign in your terms. And you can decrease that number by 2. By a positive even integer, we can decrease it by 2, but you can't take 2 away from 1, so that's the only possibility you've got for positive zeros. Now, we need to look at f of negative x to determine the negative solution. So let's think about this for a second. If I were to substitute a negative x in, what would the signs of my coefficients be? If I put negative x, if I put it to the fourth power, it's still going to remain positive, so that's going to still be positive 3. I'm going to go ahead and just write it out the way that I would. That would still remain 3x to the fourth if I put a negative x in for that. Negative x, if I put it in there and cubed it, it would stay negative, so it would be negative 2x cubed. If we put in a negative x and squared it, it would not change anything, so we would have negative 8x squared. Negative 10 times negative x, that would make it positive 10x. Minus 1 would stay the way it is. So let's see how many sign changes we have, variations in sign. Positive 3 to negative 2, there's one sign change. Negative to a negative, that's not a change. Negative to a positive, there's another sign change. Positive to a negative, there is another sign change. So there, for the negative zeros, we could either have 3, or we could diminish that by 2, so 3 or 1. So let's summarize our possibilities here. The only way that this could work, with my highest power being 4, I know that the total number of zeros for the function is going to be 4 always. So we have positive, negative, or then complex. Not complex, well, we'll write that. Complex, non-real. This means they have an imaginary part. Okay? So there is one possibility of a positive, so that's going to be 1 always, no matter what. So if I have one positive, that means that I have to have the negative. I have a possibility for 3 negative zeros. So that adds up to be 4, so that means I'd have no complex solutions at all. If I have one positive and then one negative, that means I'd have to have 2 non-real complex. The fact that I can only get the one on positive right here, that's the only possibility that I have. So I have to have at least one positive 0 for this function. So this is the way it would line up. This is the way your solutions would be. You'll have one positive and 3 negative, or one positive, 1 negative, and 2 complex. That's how that would always work for